Hello everyone, welcome to Robotics and Mechatronics tutorials. In these tutorials we present real and applicable knowledge of control engineering, robotics, machine learning, optimization, signal processing, etc. In this video tutorial you will learn how to interface a camera with ROS and OpenCV. Over here you can see real-time camera recording. To illustrate the recording process, I will place an object in front of my camera. Here is the object, and you can see that the video is recorded with relatively low frame rate. However, this is irrelevant for this video tutorial. Now, what's happening here behind the scenes? Over here, we have a publisher node. This publisher node takes an image from camera by using OpenCV. It transforms the image into the form that ROS can understand, and through an appropriate topic sends this image message to the subscriber node. And here is the subscriber node. The subscriber node receives the image, converts it from the ROS format to the OpenCV format, and it projects the image onto our screen. Here is the image and the video. The Python code of the publisher node is shown over here. And the Python code of the subscriber node is shown over here. In this video tutorial, you will learn how to write these codes from scratch and how to build a ROS package that will govern the whole process. But before I start, I would like to provide the answer to the following question. Why is this video tutorial relevant? Well, this video tutorial is very important for machine learning, computer vision, and robotics applications. Namely, you will use a camera to detect objects or to perform some kind of motion planning, analysis, or obstacle avoidance. And you need to know how to integrate camera reading with ROS and OpenCV. Eventually you will perform in OpenCV some image processing or segmentation, contour recognition, object recognition, and then you will couple OpenCV with machine learning algorithm. Consequently, this is the first step that you will learn in this video tutorial, how to perform this complete process. Also, before I start, I would like to mention the following. It took me a significant amount of time, energy, and planning to create this free video tutorial, as well as almost 300 free video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thank you very much. Okay, let's start. The first step is to install the necessary software components and to check that our camera can be recognized by Linux. Let's do that. First, connect your camera to the USB port. Then, open this program called Cheese. Cheese is a free software for taking images and recording videos, and it comes with Ubuntu. Okay, I can see an image and I can see my hand over here moving. This means that the camera is working. However, we still need to perform a few other checks. First of all, we need to check the drivers from our terminal. Let's open a terminal. Over here, type terminal. And inside of the terminal, let's type this command. We see video 0 and we see video 1. Video 0 is the device that corresponds to the default camera, and consequently this is a good sign. Let's continue. The next step is to install the ROS drivers for our camera. To do that, we will use this command. Sudo apt install ROS Noetic USB cam. Notice over here that I'm using ROS Noetic distribution. And my advice and strong suggestion is to install this version of ROS. Let's see what will happen. And of course, everything is already satisfied since I pre-installed all the drivers. However, in your case, you will most likely see an installation progress over here, and after a few seconds, everything will be completed. Good. Let's continue. Usually OpenCV comes with ROS. However, maybe while installing ROS noetic distribution you made an error and OpenCV is not installed, and consequently it's a good practice to verify that OpenCV is installed. The best strategy to do that is actually to try to install OpenCV. To do that, we type sudo apt install ROS noetic perception. This library or this package contains not only OpenCV, but it also contains other programs for perception. And you can see that basically all the requirements are satisfied. This is because I already installed this package. So far, so good. Next, we need to verify our .bash rc file in order to make sure that the ROS environment is properly installed and sourced. To do that, we need to open the file .bash rc. So let's do that. And let's inspect the file. Here's the file. At the end of this file, you should see this line if your ROS environment is properly installed. This command will simply source this script and it will execute this script every time you basically open a terminal. That is, after you open the terminal, this command will ensure that ROS is properly being set up. Okay, we have this line. If you don't have this line, simply type this line at the end of the bash rc file. So far, so good. Let's continue. The first step is to create a workspace. To create a workspace, first we will create one folder called ROS OpenCV WS. You can name this folder as you wish, and inside of this folder it's very important to create src folder or the source folder. So let's do that. And let's inspect the newly created folder. Here it is. Let's move to that folder. Okay, we can also see the source subfolder. To create our workspace, we use this command catkin make. So let's do that. Okay, next we need to source this file over here. Consequently, we will type this command. Make sure that you properly entered everything. It is properly entered. Let's verify that we have properly sourced our environment. We will type echo and then we will type ROS package. That is, we will inspect this variable ROS package path, and over here we can see the correct path to our newly created workspace. So far, so good. Let's continue. The next step is to create our catkin package and nodes. First, we will move to this folder. Let's inspect the folder. Here it is. Let's see how to create a package. To create a package, we use this ROS command, catkin create package. Then we specify the name of the package. In our case, it's ROS OpenCV. However, you can change this name. And over here, we need to specify the dependencies. We have 1, 2, 3, 4, 5, 6 dependencies. Dependencies are ROS sub-packages that we will automatically import in our new package. This package is used to transport images. This package is used to convert OpenCV images to ROS messages and vice versa. This is the standard package for sensor messages. This is ROS-Py, package necessary to run Python codes. This is ROS-CPP, package used to run C++ code, and this is the standard message package. Okay, let's create our new package. So far so good. Let's see the structure of our folder. Over here we can see our new package. Let's go to our new package and let's see what is inside. We have CMake lists, we have include folder, and we have two additional objects such as this one, package.xml file, and the source folder. Next, we need to create a folder in which we will store our Python scripts. That is, the scripts for our publisher and subscriber nodes. We will call this folder as Python script. Here we created this folder, and let's go to this folder. Of course, the folder is empty. Next, we need to create a source file that will implement the camera publisher. Let's do that. I will call the file as camera publisher.python, and I'm using the G editor to edit the file. Here is the empty file. Here we will type the Python code. However, in order to make this video as short as possible, I will simply copy and paste the pieces of code that I wrote previously. And here is the file that implements the camera publisher. I will simply copy and paste certain sections of this file. Here's the first part. Let's explain the first part. Over here, I'm saying to ROS that this file is a Python source file, and every source file that you will write in Python should start with this simple line. Next, we need to import ROS.py that enables us to use ROS with Python. Then, since we will send image messages over our topic, we need to import images. Here it is. Next, we need this package and this library. CV Bridge is a package that contains a library for converting OpenCV images into ROS image messages and for converting ROS image messages back to the OpenCV images. That is, this package serves as a bridge between OpenCV and ROS. Consequently, we need to import this package and library. And finally, we need to import OpenCV. Next, we create the name of our publisher node. I call the publisher node Camera Sensor Publisher. However, you can use any other name. Then, we need to make the name for our topic. I called the topic Video Topic. Of course, you can change this name as you wish. Next, we need to initialize our publisher node. To do that, we use this function init node, and over here we specify the node name that's defined over here. And then we specify this parameter to true. This means that ROS will add a random number to this name in order to avoid name conflicts. That is, it will make sure that we always have a unique name for our publisher. Next, we need to create a publisher object, specify the name of the topic, and specify the type of the messages that will be sent, and define the buffer size. We do that by using this function. We specify the topic name, we specify the data type of the message that we will be using, that is, we will transmit images over our topic, and we define the buffer size. The buffer size is equal to 60. Next, we define rate of transmitting the messages. We will transmit the messages or images with 30 Hertz, that is, 30 messages or images per second. Next, we call this OpenCV function video capture to create the video capture object. Next, we need to create the CV Bridge object that will be used to convert OpenCV images to ROS image messages. And that was the first part of the code. Let's explain the second part of the code. Here is where the magic happens. This is an infinite loop that captures the images, converts images from OpenCV form to the form that ROS can understand and transmit these images in the ROS form to our topic. First, we call this function read. This function will actually capture the image, and it will also have another value called return value that will be a boolean indicating success or failure. If everything is okay, we need to transmit. So if the return value is okay or true, we print the message. Video frame captured and published. Okay, next we need to convert OpenCV image, that is this captured frame, from the OpenCV form to the ROS form. And for that purpose, we use CV to image messages function, and this function is basically a method of this object, bridge object, and bridge object is constructed over here. Okay, we specified the captured frame, and this return value will be an image in the ROS image form or ROS image message form. And finally, once we do that, we transmit that message to our topic. And at the end, we wait for a certain amount of time to make sure that we transfer the image with the specified rate, and the rate is 30 Hz over here. Next, save this file by pressing Ctrl S, and let's close this window. Let's go back to our terminal. Let's see the structure of our folder. Aha, we see our camera publisher over here. However, there is one issue. We cannot execute this file since we don't have X over here. So we need to change a few things. We need to specify that this file is the executable file, and we need to add this parameter +X. So let's do that by using the command chmod, and let's see the result. Here it is. We have now the file that can be executed. Next, let's create the subscriber node. That is, let's create its source file. Again, I will be using gedit, and I need to specify the name of the file. So let's do that. Okay, here we need to type the Python code. However, to make this video as short as possible, I will simply copy and paste the file that I previously wrote. Let's first copy and paste the first part of the file. Let's see what happens over here. Here again we are saying to ROS that this is a Python source file. Then we need to import ROS.py, and of course, since we'll be receiving images, we need to import image. Then we will be using CV bridge to convert from OpenCV to ROS formats, and we import OpenCV. Next, we create the name. We give the name to our subscriber node. I call it camera sensor subscriber. However, you can change this name if you wish. And over here, we need to give the name to our topic. I call the topic as video topic. Here, you should stop for a second and make sure that this name completely matches the name of the topic name in our publisher node. If that's not the case, this code will not work. Okay, let's continue. Next, I will paste the second part of the code. Here it is. First, we need to define a callback function. This callback function is called every time the message arrives to our topic. The callback function accepts our message, that is the image. Then we need to create a bridge object. Then we need to print the message saying that we received the video message and frame. And over here we need to convert from CV bridge form to OpenCV image format. Consequently, we will take the message, and the message is in the ROS image format, and we convert this image by using this function to the image that is in OpenCV form. After we do that, we simply show our image on our screen. Then we wait in milliseconds, for example, only 1 millisecond over here, for the frame and an image to refresh on our screen. Okay, that was our callback function. Next, we need to initialize our subscriber node. We use this function, we specify the node name that's previously defined. And the next thing is to tell to ROS that we want to subscribe to topic. Here's the topic name. This is the first argument. The second argument is the data type. We expect to receive images, and consequently over here we have image, and we specify the callback function. So what's happening over here? Once the image is being transmitted through our topic, we call the callback function. The callback function will take that image, convert the image from the ROS form to the OpenCV form, and show the image on our screen. Okay. Finally, we need to spin the code. This function basically serves as the while loop. It will simply run this code and run it and run it and run it. Basically what will happen, this code will wait until the image shows. Once the image shows, this callback function will be called, this piece of code will be executed, and again we will wait until the next image arrives. If we press Ctrl+C, during the execution of this code, this function will return, and finally we need to close all the windows. So that was our subscriber node. Next, we need to save this file, close this window. Let's go back to our terminal. Let's see our file. Here is the node that we created. However, again, there is an issue with an access over here. That is, we cannot execute this file. Consequently, we need to type chmod +x and camera subscriber.py. Let's do that. Here it is. Let's verify that everything is correct. Aha, perfect. We can execute both of our nodes. However, we still need to perform one important step. Currently, our ROS and our CMake environment cannot recognize where the source files. Although they are here, we need to somehow tell to our CMake and ROS that the source files are at this folder. To do that, we need to go one folder back, and we need to edit this file, CMake lists. Let's do that. To edit this file, we will type this command. Then, search for Python. If you start searching from Python, you will start from here. Then here's the piece of code that we need to change. First of all, I will erase these comments. Then I will uncomment these 4 lines. The most important modification is given over here. Here we need to specify the path to our source files. In our case, the path is different than the path given over here. So let's correct that. The name of the folder is Python script. Consequently, over here I will modify this part, Python script. And over here we need to specify the file names. The name of the first file is camera publisher.py. Camera publisher.py. The name of the second file is camera subscriber.py. And over here we need to verify that the names are correct. Python script, camera publisher.py, camera subscriber.py. So far so good. Save this file, exit, and let's perform the next step. In the next step, we need to run catkin make. However, before we do that, we need to go to the appropriate folder. And inside of this folder, we need to type catkin make. Okay, so far so good. Now we have completely created our package, and the next step is to test this package. Let's close everything and let's start from scratch. Open a new terminal, and in addition to that terminal, open two new terminals by clicking over here. In the first terminal, we will run our ROS core. That is, we will run the ROS master that governs all the processes behind the scenes. In this terminal, we will run our publisher. To do that, we first need to source our workspace. That is, the workspace we just created. For that purpose, we need to write source and this command. Okay, let's run our publisher node. To run the publisher node, we need to type ROS run, which is a ROS command for running, the name of the package, and the name of the file. Let's run it and let's see what happens. Okay, we see some outputs. Video frame captured and published. So apparently we are capturing the images and we are publishing the images to our topic. However, I don't see over here any output, right? I don't see the image. To see the image, we need to run the subscriber node. To run the subscriber node, we again need to source our environment. Okay? And after you do that, we need to run our subscriber node. We type ROS run, the name of the package, and the name of the subscriber node. Let's press run or enter. Let's see what happens. Voila! Here's our image. Here's the camera recording, and this is actually the image that's being transmitted to our topic. You can verify that actually the system is working by placing an object in front of the camera, and you can see as I move the object, the camera is recording with relatively low rate, however it's still recording. Okay, that would be all for today. I hope that you liked this video. If you like the videos I create, please press the like and subscribe buttons. Thank you very much and have a nice day.